Hello. Today I'm going to introduce to you your Blue Book Lesson 5.5. Okay. Your Blue Book Lesson 5.5 talks about transversals. In order for us to understand what a transversal means, we need to recap some of the skills and knowledge of geometry we've already learned. First of all, we've already learned that these are parallel lines, okay? Two lines that do not intersect, okay, are parallel lines. Secondly, we've already learned that this is a straight angle. We learned that from here to here is equivalent to 180 degrees, okay? We've already learned that these are intersecting lines, and intersecting lines form vertical angles. Okay? And so that's what we've learned so far. We've also learned that two angles next door to each other are supplemental, okay? Or they're equivalent to 180, or they are adjacent, okay? So we've learned all of that. Well, we're going to take that information and combine it with parallel lines to learn a concept known as transversal. Okay? A transversal line is a line that intersects two parallel lines at exactly the right or the same angle. Okay? So when we have a transversal, which is this line here, this is our transverse line. We're going to identify it as T. When it intersects with parallel lines, it intersects the parallel lines at exactly the same angle. That means it comes in like a rocket ship, and if it hits just right, it cuts the atmosphere, or it cuts the line at the same angle across both lines. So that what we end up having are vertical lines, vertical angles, okay? And we know that this angle will be congruent to this angle, and this angle is congruent to this angle. But if this transverse is hitting this parallel line the same way it's hitting this parallel line, guess what? You're going to have the same measurement here as you would here. And if you have the same measurement here as you would here, then this angle will be the same as this, and this angle will be the same as this, and so on and so forth. Let's take a look at it. I'm going to number them. 1, 2, 3, 4, 5, 6, 7, and 8. Okay? Now, once again, we've already learned that when two lines intersect, okay, they form vertical angles. If that be the case, then angle 2 is congruent to angle 4 because they're vertical. Angle 1 is congruent to angle 3 because they are vertical. Angle 6 is congruent to angle 8 because they're vertical. And angle 5 is congruent to angle 7 because they're vertical. Okay? Now, once we have established the vertical angles, let's take a look again. We said that a transversal hits the parallel lines at exactly the same angle. If that be the case, then we should be able to take this, superimpose it, and lay it right on top of here, and it will be the same measurement, the same angles. And if that is the case, then angle 6 will actually be where angle 2 is. Angle 7 will be where angle 3 is. Angle 5 will be where angle 1 is, and angle 8 will be where angle 4 is. We call that corresponding angles. Okay? Corresponding angles. So let's take a look at it. These are congruent because they're vertical, but these are congruent because they are corresponding. And here we go. Angle 2 is congruent to angle 6. Angle 3 is congruent to angle 7. Angle 1 is congruent to angle 5. And angle 4 is congruent to angle 8 because they are corresponding angles. All because of this transversal hitting the parallel lines at exactly the same angle. We create vertical angles. We create corresponding angles. Okay? Now, in our textbook, it talks about that on page 212. Okay? And so we move on in our textbook on page 211. Okay? We are going to look at the example in our book. It talks about the ray of the sun. Okay? I hate to erase this, but I'm going to try to work over here. We have two angles, and we have a young man or a young lady who's standing, creating a shadow. And then we have a flagpole that is creating a shadow. Okay? Now, here we are and here we are. Okay? Now, according to our diagram, it says that the young man is 5 feet. Okay? The shadow is 3 feet. And the sun's ray, this is the sun's ray, okay? Now, the flagpole is X feet, okay? Its shadow is 36 feet, and this is the sun's ray. All right? Here we go. It says, use the fact that two rays from the sun are parallel to explain why triangle ABC in triangle DEF are similar. Okay? All right, so now let's take a look at it. If we use that information, two parallel lines, okay? The two sun rays are parallel. And so when we look at it, we see that we have formed right angles at the same location, okay? But it asked us to identify why they are similar, okay? Okay? Use the fact that two rays from the sun are parallel to explain why. Okay. We know that the sun's rays is parallel. That's a given. But our transversal will be what? You guessed it. The ground itself. Okay? With the ground being our transversal, we have formed two right angles here. Okay? And so therefore that angle would be congruent. Okay? And then if that is congruent, and these are parallel lines, then we can have vertical angles, okay? That this E would be equivalent to the B, and then F would be congruent to C here if these are our two parallel lines, okay? The actual shadows, vertical shadows, we can also use, okay, to help us out, okay? We can use the size 5 to 3, okay, as x is to 36, okay? And that can also help us in our solving if we wanted to solve for x, okay? So the fact that the rays are parallel and we have our transverse with the ground, we can conclude that these two are the same, okay? Now, let's move forward. From there, we're going to find out what x is, okay? And so let's do that, okay? 5 is to 3 as x is to 36, okay? And if we cross multiply, then we would have 3x is equal to 180, divide both sides by 3, and x is equal to 60. Okay? All right? And so that's what x is equivalent to. Now, let's move forward. In the lesson, it talks about perpendicular. Lines in the same plane that do not intersect are called parallel lines. Lines in the intersect at a right angle are called perpendicular lines. Okay? So what we're saying here is that at any time we have parallel lines and they intersect to form right angles, then those are considered perpendicular. And in actuality, we can have only one here, and that one will determine that all the rest are 90, because here is 90, which means here and here is 90, which means here is 90, here is 90, and so on and so forth. Okay? All right. In the exercise practice, at the bottom of page 214, let's take a look at it. It has two parallel lines with a transversal. Okay, this is T, this is L, this is 63, this is 1, this is 2. Question is, use a figure to find the measure of the angle and explain your reasoning. Okay, now we need to find 1 and we need to find 2. Okay, if this is parallel and this is transversal, then our corresponding angles will be as such. Okay, 63 will be corresponding with 1. So 1 would be 63. Okay, and if 1 is 63, then this together is 180. So then 180 minus 63, this is 10, this is 7. This will give us a 7, be 117. So this will be 117. Okay? And then according to the text, okay, that's where we are. Okay? So then, if that be the case, angle 1 is 63 because it is corresponding. Okay? Remember, if we were to superimpose and put it right on top, it will land right here at 63. Let's move on to angle 2. Or angle 2, because this is 63, is a supplemental angle. Okay, this plus this should equal 180. Okay, they will be supplemental or they can be adjacent. Would also justify this being at 117. Okay, all right, that's the example there. Let's move on to example 2. On example 2, it says use a figure to find the measure of the number of angles. Okay, so let's take a look. We have parallel lines. We have a transversal. This is 1, 2, 3. This is 59. This is 4, 5, 6, and 7. All right, they want us to find the measure of all of the angles. Okay, let's see if I can use a different color here. All right, if this is 59, this is 59, vertical angles. Okay, if this is 59, this is 59, corresponding angles. If this is 59, this is 59, vertical angles. Okay, now from there, 180 subtracting 59, this is 10, this is 7, this is 1, this is 2. Then this supplemental is 121. This vertical is 121. This corresponding is 121. And this vertical is 121. And that's how that's done. Okay? Now, let's keep going. What we need to understand are interior and exterior angles. When two parallel lines cut by transversal form 4 interior angles and then 4 exterior angles. Interior is in between the parallel lines. Exterior is on the outside of the parallel lines. Okay, moving forward. Lastly, that is it for our example on transversal and parallel lines. The only thing I want to point out is that you notice the exterior, alternating the exterior and then angles and how they correspond to each other. Okay? All right, that's it. Bye.